stop and wonder what's actually keeping your feet planted on the ground? Or what keeps the moon hanging up there in the sky and stops our entire galaxy from just flying apart? Well, today we're going to talk about the one force that rules them all: gravitation.
Okay, so we've all heard the story, right? Isaac Newton sitting under a tree, an apple falls, bam, inspiration. But just for a second, imagine if it wasn't an apple. What if it was a heavy steel bottle? Yeah, let's just say the history of physics might have been, well, a lot shorter.
Luckily for us, though, it was just an apple. And that one simple little observation, it sparked one of the biggest, most profound ideas in the history of science. The idea that the force pulling that apple to the ground is the exact same force that holds the entire cosmos together. I mean, how cool is that? So here's where it gets really interesting. Newton's big aha moment wasn't just, hey, stuff falls down. No, his real insight was that this force of attraction is, well, it's universal. It applies to absolutely everything with mass, everywhere in the universe. And the key word here is mutual. Gravity is always a two-way street. Think about it. The Earth is pulling on you right now, right? But, and believe it or not, this is true, you are pulling right back on the Earth with the exact same amount of force. It's this perfect mutual dance. So Newton, being the genius he was, captured this whole relationship in one seriously powerful and honestly beautiful formula. Now, don't let the letters and symbols scare you, okay? You don't need to be a math genius for this, because this whole equation really just boils down to two super simple, totally intuitive rules that basically govern everything.
Okay, so here they are. Rule number one, more mass means more force. Simple, right? The bigger the objects are, the stronger their gravitational pull. Kind of like a bigger hug. And rule number two, more distance means less force. The farther apart things get, the weaker that pull becomes. That's it. It's all about how big things are and how far apart they are. All right, this brings us to something that honestly trips a lot of people up. The difference between big G and little g. But don't you worry, we've got a really simple way to think about it that makes it crystal clear. So here's the best way to remember this. Think of big G, the universal gravitational constant, as your truest, most reliable friend. It's always the same, no matter where you go in the entire universe. Solid, dependable. But little g, the acceleration due to gravity, well, it's more of a fickle friend. Its value completely changes depending on your location. It's way weaker on the moon than it is right here on Earth. And this whole idea of a little g that changes, well, it leads us directly into one of the biggest mix-ups in all of science, the difference between your mass and your weight. Okay, let's clear this up for good. Your mass, that's the amount of stuff you're actually made of. The atoms, the molecules, all of it. And that is always the same, whether you're on Earth, Mars, or floating in deep space. But your weight, that's just the force of gravity pulling on all that stuff. And that can change a lot. So how much can it change? Well, get this. On the moon, where the pull of gravity is way weaker, you'd only weigh about 1/6 of what you do here on Earth. Imagine that. You'd still be you, made of all the same stuff, but you'd feel incredibly light, almost weightless. Okay, so these ideas about force aren't just for planets and distant stars. No way. They show up all the time, right here in our everyday lives, especially when we talk about the concept of pressure. And the concept here is actually super simple. Pressure is all about how you apply a force. So think of it this way. If you take a force and you focus it all down onto one tiny little point, you get a ton of pressure. But if you take that exact same force and spread it out over a big area, the pressure just drops way down. And once you know this, you start seeing it absolutely everywhere. A sharp knife cuts so easily because it focuses all your effort onto that tiny edge. Or think about a heavy backpack. Why do wide straps feel so much better? Because they spread the weight out over a larger area of your shoulder, lowering the pressure. It's even why camels have those big, broad feet. It's so they can walk on sand without sinking in. That's really the whole secret right there. It explains why a tiny, sharp needle can pop a balloon with just a little poke, but you can push on that same balloon with your whole hand, and nothing. It's all about concentrating that force. So let's step back for a second. Why does any of this matter? Well, it's pretty simple, really. Without gravity, the universe as we know it, it just wouldn't exist. You could say it's the master architect of everything. I mean, think about it.
Gravity is like this invisible set of strings that keeps all the planets dancing in a stable orbit around the sun. It's what locks our moon into its path around the Earth, and that dance is what gives us our ocean tides. And yeah, most importantly for us, it's the reason we can walk around without floating off into space.
So, let's wrap this up with one final thought. We said that gravity is a mutual attraction between any two objects with mass, right? So, why isn't your desk or your coffee cup slowly sliding across the room towards you right now? Ponder that for a moment. The answer tells you everything you need to know about the incredible, mind boggling mass of our planet and just how powerful and subtle gravity really is. Thanks for watching.